Welcome to Titocan Solutions. In today's session, we will explore the idea of data reliability, which refers to the internal consistency among variables in a dataset. Usually, questionnaires are designed to measure abstract concepts, which are also known as constructs, that cannot be observed or measured directly, such as attitude, satisfaction, depression, motivation, anxiety, psychological traits, or self-esteem. When these constructs are measured using multiple items on a Likert scale, it becomes essential to confirm that all items are working together cohesively. This is where Cronbach Alpha becomes valuable. It helps determine whether the items collectively reflect a consistent and reliable measurement of the construct. So in this video, I will demonstrate how to use SPSS to conduct a Cronbach Alpha test to check the reliability of your questionnaire. Whether you are working on a thesis, academic research, or a product feedback survey, this is an essential skill to have. So stick with me on this channel and follow along to the end. My name is Titocan and this is Titocan Solutions, a YouTube channel for improving the knowledge of how to do things. Now, what is Cronbach Alpha? Cronbach Alpha is a statistical index that measures the internal consistency of a set of items in a questionnaire. It tells us how closely related a set of items are as a group and how reliably they measure the same underlying construct like attitude, satisfaction, depression, motivation, anxiety, psychological traits, or self-esteem. It's commonly used when you have multiple Likert scale questions in a questionnaire survey that form a scale designed to measure a single underlying construct. Cronbach Alpha coefficient ranges from 0 to 1, and higher values generally indicate greater internal consistency. The following coefficients are the indices for interpreting Cronbach Alpha. If Cronbach Alpha is equal to or greater than 0.90, it means the reliability is excellent, but may however suggest a redundancy. If Cronbach Alpha ranges from 0.80 to 0.89, it means the reliability is good. If Cronbach Alpha ranges from 0.70 to 0.79, it means the reliability is acceptable. If Cronbach Alpha ranges from 0.60 to 0.69, it means the reliability is questionable. If Cronbach Alpha ranges from 0.50 to 0.59, it means the reliability is poor. And if Cronbach Alpha is less than 0.50, it means reliability is unacceptable. Now, let's proceed to inspect the dataset we are using for this demonstration. In this tutorial, I'll be using this dataset to perform the analysis in SPSS. As you can see, it has already been loaded into SPSS. If you don't know how to load data into SPSS and define the variable properties, please visit Titocan Solutions YouTube channel to see or watch my video on Introduction to SPSS Software for Beginners, Part 1 and Part 2. This data simulates responses from 40 university students who participated in an online learning program. Each student was asked to rate their level of satisfaction with various aspects of the online learning experience. They responded to 10 survey items, each designed to measure a different dimension of online learning satisfaction, such as ease of access, instructor engagement, quality of course materials, technical support, and overall learning outcome. All items were rated on a 5-point Likert scale ranging from strongly disagree to strongly agree. To view how the survey items correspond with their Likert scale ratings in this data view window, click on the value labels icon to toggle the display. As you do this, you will notice that the data alternates between numerical values and their corresponding text labels within each cell. Now, let's switch over to the variable view window to examine the properties of each item. Now, since all variables are labeled similarly, you can click on any cell under the values column to check how the Likert scale was defined or coded. In the dialog box that appears, you will see that strongly disagree is coded as 1, disagree is coded as 2, neutral is coded as 3, agree is coded as 4, and strongly agree is coded as 5. This indicates that the responses are arranged in a specific order, making them ordinal in nature. Therefore, The scale of measurement for these items should be ordinal. Now that we have confirmed the data is correctly structured for Cronbach Alpha analysis, you may want to ask, does this survey instrument demonstrate internal consistency? Before we proceed with the reliability test to answer that question, there are a few important assumptions your dataset must satisfy to ensure that the analysis results are valid. These assumptions include the following. 1. The items should be positively correlated. 2. The data should be continuous or ordinal in scale, such as Likert scales. 3. The items must be intended to measure the same construct. That is, Cronbach Alpha construct must be unidimensional. 4. The sample size should be reasonably sufficient. More preferably, there should be 30 respondents and above. 5. There must be no missing data. And 6. There must not be dichotomous or binary items in your dataset. I have checked with my data and they satisfied all the assumptions. Please, before you run your own analysis, you must ensure that your own data satisfy all these assumptions. Otherwise, the result you will get may not be a valid output. Now, let's return to our dataset and perform the reliability test. However, if you are using SPSS version 25 and earlier versions, you will be able to follow the procedure demonstrated in this video. Now go to the menu bar and click on Analyze. From the sub-menu, put your cursor on Scale, and from the drop-down options, click on Reliability Analysis to open the dialog box. In this dialog box, your variables are in the left box. Now, click on the first item, hold down the Shift key on your keyboard, and click on the last item to select all the variable items. Then, click on this transfer arrow key to move them all to the items box on the right. Now, come to the model part, and as you can see, the default option is Alpha. This is what is used to instruct the SPSS system to run Cronbach Alpha. So, you should leave this default choice unchanged. But if the default choice is not Alpha, please click on the button and select Alpha from the options as the required choice of model to run. Now, click on the Statistics button to open the dialog box. In the descriptive section, check the boxes for item, scale, and scale if item deleted. And in the inter-item section, check the box for correlations. These are all the configurations that you need to perform Cronbach Alpha. Click Continue to close this dialog box. Like this, we have successfully completed the configuration process to perform reliability tests in SPSS. Now, go ahead and click OK for the SPSS system to process the input and produce the results in the output window. As you can see, the results have been produced. I will now interpret the results in the best way you will understand. The first result here is the case processing summary table. This table plays an important functional role in understanding the number of data points or cases SPSS actually used in the analysis and how many were excluded. It helps you verify that your dataset is clean. So as you can see from this table, the number of valid cases of data used for the analysis is 40, accounting for 100% of the entire data used, meaning there was no missing value as all the data points or cases were used to run the reliability test. The next table is the reliability statistics table. This table is the core output of Cronbach Alpha analysis in SPSS. It provides the numerical evidence that allows you to determine whether your scale or questionnaire is reliable. That is, whether the item consistently measures the same underlying construct. As you can see from this table, the Cronbach Alpha is 0.820, which falls within the range of 0.80 to 0.89, indicating good reliability and showing good internal consistency. This suggests that the 10 items in the instrument or questionnaire are consistently measuring the same underlying construct, such as online learning satisfaction. The Cronbach Alpha based on standardized item is 0.818, indicating that item variances were balanced. However, the standardized alpha of 0.818 is very close to the raw Cronbach alpha of 0.820. This indicates that the items already have similar variances, so standardization does not change the reliability estimate significantly. In a simple term, what this means is that the items are balanced and well scaled. The number of individual items or variables is 10. This confirms that you included 10 items of variables in the scale. With 10 items and Cronbach Alpha of 0.820, you have a well-functioning scale with enough items to ensure stability, but could risk redundancy. Generally, looking at this table, it can be concluded that the instrument is a reliable measure of the construct under study, since all 10 items contributed positively to the scale. The next table of result is the item statistics table. This table presents basic descriptive statistics such as the mean and standard deviation of each item and helps to identify item redundancy or lack of variation in responses. It offers a quick way to see how respondents are scoring on each question. If the mean values are extremely low as 1 or extremely high as 5 on a Likert scale, it may indicate ceiling or floor effect, suggesting that items may not be discriminating well. On the other hand, wide standard deviation indicates greater variability, which can help spread and improve the inter-item correlation up to a point. So as you can see from this table, the mean value for the 10 items are greater than 1 and less than 5, meaning that they are neither extremely low nor extremely high. Again, the standard deviation for the 10 items ranges between 0.853 and 1.051, indicating a very wide variance that can help spread and improve the inter-item correlation up to a point. The next table of result is the inter-item correlation matrix table. This table shows the correlation between every pair of items in your scale and offers a bird's eye view of how all items relate to one another, helping to assess whether your scale is unidimensional, that is measuring one construct, or multidimensional, that is measuring multiple constructs. Typically, ideal inter-item correlations are usually between 0.20 and 0.60. Very low correlations of less than 0.20 suggest that the items may be measuring different constructs, and very high correlation of greater than 0.80 may indicate redundancy, where two items are too similar. A well-balanced matrix shows that all items are moderately interrelated, supporting internal consistency without redundancy. So as you can see from this table, there is no pair of items that has ideal inter-item correlation coefficient less than 0.20 or greater than 0.80. Suffice to mean that the scale of measurement of the items is unidimensional or measuring one construct, and items are working together without redundancy. The next table of result is the item total statistics table. This table provides a deep diagnostic look into the function and quality of each item within your scale and helps to determine whether individual items contribute positively or negatively to the overall scale reliability. It also helps to determine which item may be underperforming or redundant, as well as how reliable your scale would be if one of the items was removed. This table supports informed decision about retaining, revising, or removing items in your questionnaire. In this table, there are 5 columns. The first column here is the scale mean if item deleted. This column indicates the total mean of the scale if a particular item is removed. As you can see down the column, item number 7 has the lowest value of 32.40, while item number 3 has the highest value of 32.72, meaning that the values ranges from 32.40 to 32.72, suggesting that each item contributes approximately equally to the total scale score. There is no extreme deviation, which means no single item is disproportionately affecting the total score. Generally, the scale mean remains stable across all items, which is a good sign of balance, because removing the lowest item will increase the overall scale mean slightly, and removing the highest item will lower the average the least. I hope you understand this. The next column is scale variance if item deleted. This column shows the total variance of the remaining items if one is removed. In this column, item number 10 has the lowest variance, which is 27.126, showing that the scale becomes more homogeneous without this item. The higher variance is displayed by item number 8, which is 30.923, suggesting more variability among remaining items if that item is dropped or removed. Generally, most items fall within a consistent variance range. Items number 10 seems to reduce variance, indicating tight internal consistency when it is removed and is worth checking further. The next column is corrected item total correlation. This column presents information that measures how well each item correlates with the other score of the other items, excluding itself. If the value is less than 0.30, the correlation is problematic or poor. If the value lies between 0.30 to 0.50, the correlation is acceptable, while if the value is greater than 0.50, the correlation is said to be good. So as you can see from this column, the lowest and highest value range from 0.379 to 0.673, accounting for item number 8 and item number 10 respectively. This means that all items are above 0.30, meaning no item is clearly poor. However, items number 4, which is 0.382, and item number 8, which is 0.379, might be weaker in consistency than the others. This is what this column in this table is telling us right now. The next column is squared multiple correlation. This column reflects how much of the variance in each item is explained by all other items. This column functions like the arrow square in linear regression analysis. Higher values in this column shows that items fit well within the scale model. So higher values are more preferred in this column. As you can see for yourself, item number 10 has the highest value of 0.646 and so is the most predictable from others, while item number 4, which is 0.283, is the lowest value, which is obviously less explained by other items and therefore the least connected to the group. The final column of this table is Cronbach Alpha if item deleted. This column tells us what the new Cronbach Alpha coefficient will be if that specific item were removed from the scale. If the values in this column are higher than the overall Cronbach Alpha, the item may be hurting the reliability and should be reconsidered. Now recall that our Cronbach Alpha from the reliability statistics table was 0.820. This value is the basis for comparison with values in this column. So as you can see from this table, values here range from 0.783 to 0.816, meaning no value is as big as the overall Cronbach Alpha of 0.820. Therefore, no item needs to be removed because doing so may hurt the reliability as the alpha if deleted values will drop from 0.820 downward. For example, if we choose to remove item number 3, then the alpha if deleted value will now be 0.798, indicating a drop down in value compared to the overall Cronbach Alpha of 0.820. This means that this item number 3 is very valuable to the scale. The same thing applies to item number 6 and item number 10. Rather than remove items whose alpha if deleted value would be far lower than the overall Cronbach Alpha, you should consider removing items whose alpha if deleted values are higher or very close to the overall Cronbach Alpha. In this table, trying to remove item number 4 and item number 8 may slightly improve alpha, as 0.816 for item number 4 and 0.815 for item number 8 are very close to the overall alpha of 0.820, but they may be considered as weaker contributors. So in this table generally, it appears no item drastically harms the scale, as all 10 items show acceptable item total correlation above 0.30. But item number 4 and item number 8 demonstrate the lowest performance across multiple indicators. Removing either of them will slightly increase Cronbach Alpha. Conversely, item number 10 strongly supports the reliability of the scale and should be retained. Overall, the scale demonstrates good reliability and item coherence. You should do the same thing if you have a similar condition of alpha if deleted with your real-world data. The last table of results here is the scale statistics. This table showcases the descriptive statistics of the data, such as the mean, variance, and standard deviation. I am confident you can interpret this last table on your own, because right now we have come to the end of this video, and I hope you'll be able to replicate the procedure to run the analysis on your own dataset and interpret the result. But wait, don't stop here. If you found this tutorial helpful, click the like button, share this video, and subscribe to Titocan Solutions for more data-driven insights. And then turn on the notification bell so you never miss out on our latest tutorial. Do you have questions? Drop them in the comment section. Let's keep the learning going. And hey, if you are working on a real-world project and you need guidance, let's talk, because learning never stops. Thanks for watching. Thanks for sharing this video, and thanks for subscribing to Titocan Solutions, a YouTube channel for improving the knowledge of how to do things. See you in the next video. Bye.